In this lecture, we'll use some vector arithmetic to get our two laser particle systems properly pointing towards our target point. Before we jump straight into that next topic, let's just quickly get rid of this pesky little sphere collider that I'm seeing dangling in our scene view. So here on our player rig, our target point, we properly disabled our mesh renderer, but we can actually just delete this sphere collider altogether. I don't want it interfering with any sort of other colliders or triggers we might have in our scene later on. The goal here is to get our two laser particle systems pointing towards our target point off into the distance. To do that, we need to just have a brief conversation about some vector arithmetic. Vector, math, or arithmetic might sound overwhelming at first, but like many things, once you understand the basics, it starts to become demystified. One of the most common things you'll need in game dev is getting the direction you'd like to aim or shoot something. We can properly achieve that anytime we have two different vector 3s. We can use vector subtraction in a way to get both the direction and the distance. That doesn't necessarily mean that if you subtract point A from point B, you'll immediately get a direction and a distance. However, you will get a new vector 3. You can then use that new vector 3 to get things like magnitude, direction, or distance. So the easy thing to remember is that anytime you need a specific direction, you can go from where you're starting all the way to where you're ending, subtract point A from point B, and then you can then use that new vector 3 to get both the direction and the distance. And luckily, Unity has some built-in Unity methods to help us get there. Things like quaternion.lookDirection or vector3.distance, for example. So using this newfound knowledge, let's go do that in our player weapon class. Let's create a new function here at the bottom that we can just call void aim lasers. Now we're going to want to do this for both lasers. So how do we do that? Well, we can just use a for each loop. We can just follow this same syntax that we use above here for both of our lasers. Let's replace var with GameObject. Let's just replace the generic item term with laser in our array up top that we called lasers. Let's get that new vector 3 from subtracting two vector 3s that we already have. Let's just call that new vector 3 fire direction. How do we get that? Well, we start with point B, the direction we're trying to head, in this case, our target point, dot position to return a vector 3, minus our laser dot transform dot position. That will give us these two individual lasers separately. Now, each individual laser has a slightly different transform. I'm actually tempted maybe just to use the ship's transform. Maybe we can try both and see which one gives us a better result. For now, let's just start with each individual laser's transform and see what that looks like. We can now use this fire direction vector 3 using a Unity built-in method called quaternion.lookRotation to get the direction we're trying to aim towards. So I'll leave a link to the Unity documents if you'd like to do a little bit more reading inside what look rotation exactly does. For now, we can just store this value in a quaternion called rotation to target. And then we can use that built-in Unity method quaternion.lookRotation. Why isn't that auto-populating? I'm actually seeing I have some squiggly lines here. I think that's because somewhere along the lines I tried to type lowercase quaternion perhaps, and it imported the system numerics namespace. Not exactly sure. I'm going to delete that. It's giving me some vector errors. We've got rid of those squiggly lines, and now my look rotation should properly autocomplete. Great. We need to plug in our new vector 3 fire direction. With that stored quaternion, we can take laser.transform.rotation of each individual laser and just set it directly to our rotation to target. Let's recap these three lines to be as comprehensive as possible because it can be a little bit confusing to follow. On line number 1, we're subtracting the laser position from the target position, which will return and give us a vector between the laser and the target point. On line number 2, we can use quaternion.lookRotation, which will calculate a rotation for the laser that will align it to the vector that we just calculated. On line number 3, we can move the laser's dot rotation towards the quaternion that we just calculated. Hopping back up to line number 1, we have the option on exactly how we want to calculate this first vector 3. Do we want to use our ship's transform dot position, or do we want to use each individual laser's dot position and calculate it from there? We'll try both and see which works better. When do we want to update this? Probably just in update, at least for now. Let's just throw it directly in update aim lasers to make sure that's firing properly every frame. All right, I think we're all set here. Let's go check back in Unity and see how we did. Let's blow up my game view, give it a whirl, hit the play button, and I think we should have our lasers firing off in the direction of our red bullet. And you know what? That's already looking pretty good. Now you can see because of where we set that red target point off into the distance, way off into the distance, our lasers are actually starting to cross one another. It would be interesting to see just what that looks like if we use our player ship's rotation, so we're not using each individual laser. I'm just going to go try that real quick. Let's just see what that looks like. Inside of our aim lasers method, instead of using each individual laser's transform, let's just actually use our player ship. So we can actually just delete laser entirely. It will implicitly know that this transform here is the transform of the game object that this class is attached to, in other words, our player ship. Now, sometimes this can be a little bit abstract, so sometimes I like to use the this keyword. You don't need it, but just to make things explicit, letting us in the future know that when we say transform position, it just means this specific transform position of the game object attached to this class. Let's see if that gives us any sort of better result. Hit play, fire off way into the distance somewhere. I think they should be staying side by side at least a little bit more, if not entirely. I kind of need my ship to stay still so I can properly look at it. Let's just wait until we get all the way to the end, and then I'll just put my cursor off into the distance to see if that has any sort of better result. Definitely a different effect. It's a little bit lopsided. It's probably lopsided in the other direction over here, depending on where you're exactly aiming. Probably a personal game design preference. Maybe we can test and tweak this a little bit later on. We're going to need to tune and tweak maybe the distance of the ball a little bit more, but I think we need some targets, some ships to blow up first before we tune and tweak too much. When you're ready to implement some new features, I'll see you on the next one.